Hiya, how you doing? In this video I'm going to talk to you about quadratic inequalities. Okay, this is what one of them looks like, and the questions are normally phrased like this: find the set of values, okay, set of values of x for which, and then the following. It says x squared subtract 4x subtract 21 is less than 0. Okay, so with an equation it asks you to solve for x, find a value or find the values of x. With an inequality, it asks you for a set of values, okay? So your answer is going to be an inequality itself, okay? Right, here's the inequality we're going to look at, and the advice is to solve it initially as if it's an equation. So you don't have to write this down, but I'm going to do it anyway to show you what I mean. Just treat it like an equation. Just come back to the inequality towards the end, okay? So if we look at it as an equation, then we go to solve that. Most of these factorise, okay, because that's not what they're testing on really. They're not testing on your ability to use a particular method to solve a quadratic, okay? They're testing on how you can actually apply the inequality a bit towards the end, okay? So normally these factorise, so let's have a look. That would be x subtract 7 and x plus 3, won't it? Okay, you can just check that. Negative 21, negative 7 plus 3, negative 4, yeah, great. And then normally your next step will be therefore x is 7 or negative 3. But because it's not actually the final solution we're looking for, I'm going to write down something else instead. Sorry, rub that off. I was about to write a critical solution. We call these critical values, okay? The critical values are going to be 7 or negative 3. And when we say critical, it means the inequality will be something to do with the numbers 7 and negative 3. Well, what are they? That's what we're going to find out. There's two methods that I'm going to show you that will help you to find what the inequality is, okay? Let me show you the first method, because it's the preferred method, to be honest, because once you get used to it, it's much, much quicker, okay? You should be reasonably comfortable now with sketching graphs and sketching quadratic graphs. If you're not reasonably comfortable, get some more practice. I can't tell you enough just how important sketching graphs actually is. These quadratics, they're very basic in the grand scheme of things, okay? Just wait until in year 13, then you'll see what proper graph sketching actually is, okay? But these are pretty basic. So the critical values are 7, negative 3. So what I'm going to do is I'm just going to put them here and here, okay? So 7 and negative 3. Because in a quadratic equation, that's where the graph would cross the x-axis, okay? And you know, because it's a positive x squared graph, okay, because the coefficient is a positive value, okay, it's going to be a U-shaped looking parabola, and you don't have to get it absolutely accurate, but there we go. You don't even have to label the y-intercept, but I'm just going to do that for completeness, okay. And that's what the graph looks like, okay. It's a minimum value somewhere between negative 3 and 7, well, exactly actually, between negative 3 and 7, okay. Then we look back to the inequality, okay. The inequality is this, okay, solve when that is less than 0, okay. The right-hand side of it refers to the y-coordinates, okay? Because what we've plotted is the graph of y equals x squared, subtract 4x, subtract 21. So when we're saying what happens when this is less than 0, we're effectively asking when is y less than 0, okay? When are the y-coordinates less than 0? Well, the y-coordinates are basically defined by the y-axis, aren't they? Any positive y-coordinate is above the x-axis. Any negative y-coordinate is below the x-axis. And what are we looking at? We're looking at this part of the graph here. Okay, if I just trace over it again, that is the bit that is below the x-axis. This is the bit where y is less than 0. And you can visually see that, which is why it's my preferred method. Okay, so the values of x we're looking for are between here and here. So the way we write that is like this. Okay, we'll write it out first. X lies between negative 3 and 7, but it reads as negative 3 less than x less than 7. Basically, if x is in the middle of the numbers, okay, just put it in the middle of the inequality with the lowest and highest, okay? And that's it, okay? That's your answer, okay? Let me show you the other method, okay? It's normally called the table method in my classrooms, okay? But I'm going to show you how we use it now, okay? Having got to this stage here, critical values of 7 or negative 3, there exist three possibilities of what your final solution looks like, okay? The three possibilities of these, either x will be less than your lowest possible number, or it will be greater than your highest possible number, or somewhere in between. That covers everything. Let me write them down as statements, okay? So you've got either x is less than the lowest number, negative 3, or you've got x is greater than 7, or it's got to be in the middle, isn't it? Okay. Yes, I know we know what the answer is, but let me show you how to actually get it. Okay. Those are the only three possibilities that exist, and that's what happens with all quadratic inequalities. Okay, you'll have three possibilities after your critical values. You'll have less than lowest, greater than highest, or something in the middle. The only exception is when you have equal roots, of course, for this bit. Okay. Then you just test it out. Okay, just choose any number that lies below -3. So try, say, -5. Doesn't have to be a difficult one. Okay, x equals -5, and then test it out. Okay, just put it in there. Okay, or its factorised form, and see what happens. Okay, if you put it in there, so you get -5 squared, it's 25. Subtract 4 times -5, so that's plus 20, and then subtract 21. Okay, 25 plus 20 is 45. Subtract 21. Is that less than 0? No, it's not. It's not less than 0. Okay, so that's not working. So I'm going to cross that out. Okay. This one next. Okay, so put in any value of x between -3 and 7. So the easiest one to go for is x equals 0. Okay. So then put it in there, so 0, subtract 21. Well, I don't have to write that down. You can see -21 is less than 0, so that works. Okay, and then try a number that's greater than 7. I usually go for nice round values. In this case, like x equals 10. Okay, put it in here. So write down 100, subtract 40, subtract 21, 60, subtract 21. Is that less than 0? No, I don't think so. That's not less than 0, is it? So that's not a possibility either. Okay. So what we've done is, by testing values, we've affirmed that actually it works between -3 and 7, but we've also shown that it cannot work in this case or this case there. And so that's your answer you write down. Okay. First, I think it's a little bit longer, okay, because the graph sketching, you need to know how to sketch graphs anyway, so just get some extra practice in sketching the graphs and go ahead and use that method. Okay. Right, that's that example. Let me show you another one. I'm hoping you found that one helpful. Okay. Every now and again I try and move away from the board, just in case you want to get a screenshot of this or something, or just if you wanted to press the pause button, you can get a nice clean view of everything that I've written down. Okay. I don't worry about the speed at which I rub things off, because obviously being a video you can pause the video and play it again. Okay. So -x squared plus 7x subtract 10. I've written these. I've written these down because I don't want to mess these ones up. These are sort of things that, you know, could look rather awkward if I don't actually think about it before. Okay. Anyway, this one here. So -x squared plus 7x subtract 10 is greater than or equal to 0. Okay. Well, obviously you can treat this like an equation, like I said in the previous example, and in doing so, you have the opportunity to multiply everything by -1 if it makes it easy. Okay, so look, if I multiply everything by -1, I get x squared subtract 7x plus 10 is equal to 0, like that. Okay. Be very careful. If you multiply that by -1, yeah, without changing that inequality to an equal sign, you'll have to flip the inequality around. Okay. Do you know why that is? Let me just show you quickly now. I'm going to write down an obvious statement. So 9 is greater than 5. Yeah, obviously. If you double that, 18 greater than 10. If you triple it, 27 greater than 15. Always works. But as soon as you multiply by a negative number, like -1, is this true? Is -9 greater than 5? -5? No, it's not. The rule is you change the inequality around if you're going to multiply the inequality bit by -1. Okay. So I just thought I'd throw that in there. Oh, it's only best to multiply by a negative value when you've got an equation. Okay. So we've got that, x squared minus 7x plus 10 equals 0. As I said, most of these factorise, so how's that one going to go? So it's going to be, yeah, -2, let's subtract 2, x subtract 5. Okay, yeah, that will work. And then your critical values, okay? I know it's a pain to write down critical values, use CV if you wish, okay, but you shouldn't write x actually equals without some sort of explanation, okay, because x equals 2 or 5 is not the actual solution to your inequality, okay. Then I sketch the graph, okay. Now this time, to make sure I don't get it wrong, okay, I'm going to refer you back to the original equation, okay, and point out there, you can see that's a -x squared graph. It's going to be a U shape. Sorry. What did I do there? I said it's going to be a U shape. Yeah, good one. It's a bit like saying it's a vertical line or it's a horizontal line. So I'll say it again. It's an N shape. You know why it's done? Parabola. Okay. with the critical values of 2 there and 5 there. Okay, so N-shaped parabola, so just draw it something like this. Okay, it doesn't have to be accurate, you don't have to make it cross the y-axis. I'm just going to do that to remind you that it does. And there's a y-intercept there of -10, of course. Yeah, that's what the graph looks like. So I've just drawn the graph y equals -x squared plus 7x subtract 10, and whereafter, when that is greater than or equal to 0, notice I've written it like that for you, y is greater than or equal to 0. So this time what you're after is everything above the x-axis, or the y-coordinates must be positive. So that's this part of the graph here, okay? See that? So that's that part of the graph there. And that is between x is 2 and x is 5. So you write your inequality, hopefully you can see it down there. 2 less than or equal to x less than or equal to 5. It's always worthwhile checking, okay? Look at the symbol there, that's an or equal to symbol. So you need an or equal to symbol in your answer there. Okay? If that was a greater than, then you just change it like that, okay? And then it would be correct. And just change that for. Anyway, yeah, so that was that one, okay? And obviously the thing for you to do is just practice as many of these as you possibly can, all right? Ooh, what was that little fade into black, fade back into this bit about, okay? Well, what it was about was I watched my original video again, and I thought I can insert another example in here. That's exactly what I'm doing, okay? I'm inserting another example right here, right now, okay? This is the example I wanted to insert, okay? Because it's a nice one to show you. So you've got 3 over x is less than 1, okay? Now what would you normally try to do to solve that, okay? Normally if it was an equation, it would be like this, 3 over x is equal to 1. You'd multiply both sides by x and you get that, wouldn't you? 3 equals x. Job done, okay? Quite a simple thing. But this is not an equation, this is an inequality, okay? Because what I'm going to do is I'm going to show you quite simply why that's not going to work, okay? Well, suppose x is equal to -5, for example, okay? Then you've got 3 over -5, that's -3/5. Of course, it's less than 1, okay? So that's a possible solution, isn't it? But if you're multiplying both sides of an inequality by a negative value, the inequality no longer holds, okay? The inequality no longer holds. Let me just show you, if I multiply both sides by -5, okay? So I get 3 on the left, -5 on the right. Is that still true? No, it's not, is it? Okay, you'd have to flip the inequality around, okay? So be careful. When you've got an inequality and you feel the need to multiply both sides by a variable, such as x, make sure that you guarantee the variable you're multiplying by is positive. And the only way of guaranteeing that is to multiply both sides by x squared. And that's your method for these types of inequalities, okay? When you've got a denominator that's an algebraic term, such as x, okay, multiply by the square of that denominator. So I'm going to do that now. Okay, so if I multiply both sides by x squared, I'm going to get 3x on the left, and I'm going to get x squared on the right. And the inequality is not changed. It's still 3x is less than x squared, because I basically multiplied both sides by a positive number. I'm hoping that made sense to you, okay? And I'm just going to rearrange this. So I've got x squared subtract 3x is greater than 0. Hopefully you can see what I did there. So I just put the 3x into that side, and then x squared minus 3x is greater than 0, and written it like that, okay? And then factorise it, x minus 3, okay, it's greater than 0. Critical values, okay, let's just write those down. X is equal to 0 or 3, and then quick sketch of the graph now. So 3 is there, 0 is there. There we go, and that's it, okay? Notice I was able to do all of that this time without putting the equals 0, treating it like an equation, critical values, I kept the inequality in. Okay, you can do that as well as you get more familiar with these. And what we want to do is we want to have whenever y is greater than 0, don't we? So that is going to be greater than 0, so whenever y is greater than 0. And that happens here and here on the graph. So either x is less than 0 or x is greater than 3. Okay, so 2 possibilities there. Remember the or. Okay, the or is important because you cannot have a number being both less than 0 and greater than 3 at the same time. It doesn't work. In maths, that doesn't work. In maths, and strictly means it's got to happen at the same time. I suppose it means that in English as well, doesn't it? Okay, but you know, this is maths, isn't it? So you write or for less than 0 or greater than 3. Okay, I'm hoping that made some sense to you. You can always check in the original inequality. So pick a number that's less than 0. Well, I showed you the number with -5 and -3/5 is less than 1, so that works. But let's choose a number that's greater than 3, like +5 this time, or 10, 3/5 or 3/10. That's still less than 1, so that works, isn't it? Okay. And if you really want to test it, choose a number between 0 and 3. 1 seems an obvious number. Okay. 3 divided by 1 is 3. Is 3 less than 1? No. Okay, it's not. Okay. And I've just shown you the table method there very, very quickly. Okay. So that's that example there. So let me just pop this off and I was going to talk during my rubbing off moment, okay, but yeah, I thought I'd just give you some time to reflect. Okay, reflection time is good, isn't it? Last example, I wrote this down actually. So 2 is greater than 7 over x, plus 4 over x squared. Okay. See, this is the original question that came up before the fade into black moment earlier. Okay. And the reason I changed it is because, you know, what are you going to do? You're going to look at the lowest common denominator there, which is going to be x squared. Okay, and you can multiply through that by x squared, aren't you? But the thing is, I wanted to cover an example which showed you why you shouldn't just multiply through that by x. And this example doesn't show you that, does it? Because you have to multiply through that by x squared anyway, which of course is positive. So that's why I inserted that example we just sorted out. Okay? So the method is you multiply through that by x squared to get rid of the fractions, of course. On the right hand side, you get 2x squared, and then on the left hand side, you get 7x and then plus 4, and then that is it. Okay, and then you just rearrange it. Okay, so I want to get everything onto one side, so I'm going to write it like this. Okay, so 2x squared subtract 7x subtract 4, and then you're ready to go with the factorising. Okay, so this is slightly different for two reasons. One is, yeah, it's an equation with it's an inequality with algebraic fractions in it, but also you just got to rearrange it a little bit as well. Right, these normally factorise, as I have said. Okay, so 2x there, x there. Can you think about what goes in here and here? I'm thinking to get the 7, we need to have a 4 there and a 1 there. Okay, so 8 subtract 1, 7, so I'm with that negative. Okay, so negative 8x plus x is negative 7x, and then negative 4 gives you that. Okay, and then I will go for the critical values. Okay, and then critical values are x is equal to -½ from that bracket, or 4 from that bracket there. Okay. Then I'll just sketch the graph. Which graph am I going to sketch this time? I'm going to sketch that one there. Okay, so that's -½ that's 4. Okay, U-shaped parabola, just through that. Oops, didn't quite go through the cross. Let me just change that slightly. Okay, and just for completeness, I'll put in the y-intercept as well, -4. Okay, and I'm looking at whenever y is greater than 0, because that is greater than 0. Okay, so two possibilities. Okay, either this bit there, because that's above the x-axis, or this bit there, because it's above the x-axis. So it's either going to be x is less than -½ or x is greater than 4. I can just squeeze it in here. X is less than -½ or x is greater than 4. And those are my two possibilities there. Okay. Right. I'm hoping you enjoyed that. Okay, and I'll see you again soon. Bye bye.